Mobile applications and mobile testing. What is mobile? Yeah, what is a mobile phone? Mobile phone is also called a cellular phone, a handset and all this. Means without wire. Simple. It depends on the, like before actually in 1876 phone was invented. You know who created that, right? So I don't have to. Actually there was another person before Alexander Bell who really had that concept. But he didn't get it right. Then Alexander Bell actually really he patented it actually. He's the first person to patent the phone concept and everything. Okay. Alright. So mobile phone is nothing but it's also called cellular phone, cell phone or a hand phone. It's a device to make, you know that like we make calls, receive calls, and not only that, how does all this mobile phone work? How do they transfer their data and everything? What are the signals called? Radio signals. For example, see, everything is a radio signal now. For example, if you go past a toll gate, it's a radio signal. Even Bluetooth is a radio signal, right? Bluetooth is also. But see, we call Bluetooth as Bluetooth. That is also cellular waves and everything. How does it matter? For example, same radio signals. One is called Bluetooth. One is called near field communication. One is called cellular signals. One is called how they are differentiating if it is the same radio signal. How it is not interfering? Anyone? It's frequencies. The frequencies which matter, and the how far they can go. That is also the matter, and the complexing. That is called multiplexing. How much divisions channels are there in each frequency? That is called multiplexing. So that is what makes a technology different. And how they find their source and target. How they find source and target. For example, if you pass through a toll gate, automatically there will be a receiver. It will be actively looking for chips, and it will be giving a radio signal, and it receives it. So it is receiving. For example, there is near field communication. Near field communication means, for example, if you go near to it, it will grab you. Means it will identify you and it will give response to you automatically. So these are near field communication. So these are different things. Okay. So but you know that it's all radio signals. Okay. Yeah, and generally when it is over an area, over a location, over a region, over a state, over a country, you need operators. You need operators, you need towers and all this kind of stuff. Okay. Looks like someone couldn't join the class. 1 second, give me 1 second. Alright, I am back. So, who started mobile phones first? Motorola company. Motorola is the first company to create a mobile phone. It used to be a huge handset and it costed like $3,000, $3,500 at that time. It was called some micro-tac. It was called micro-tac. Okay, and the thing is, later smartphones came into picture. Mobile phone is different, smartphone is different. Mobile phone, if you remember your Nokia phones and everything, that is also mobile phone. Everything is a mobile phone. Agreed. Even some handsets which can go far from your receiver and everything, that is also a mobile phone. Later, smartphones came. Means operating systems developed. So if there is a phone, for example, if you want to access the contacts list also, there is an operating system inside it. There is a software running in it, which is collecting which is a combination of some other softwares on it. So who is the first mobile operating system for smartphones? I'm not talking about really the other kind of phones. It's Palm OS. Remember there were PDS before. We used to have we used to have the stick to, big stick to. So that is the Palm OS. Palm OS is the first mobile operating system in 1996. And in 2007 something happened. What happened? iPhone came. And it came up with the operating system called iOS. In 2008 something happened. Android came. It took over the world. iPhone took over US, Android took over the world. Okay. Let's see later how it went. Yeah. Mobile phones, so we can connect to any phone here. Like we can connect to any phone. So using a radio signal, we'll connect to a tower and then we can connect to any phone or anything. There were generations of these networks. These are not generations of phones. These are generations of networks. For example, someone will say my phone will support 3G. Oh, in India there is no 4G yet. Someone will be asking some other person, right? So what does this 1G, 2G, 3G, 4G means? 1G is a generation of mobile phones where it is only voice only. Agreed? It was meant for voice only, not even text messages too, not even SMS or anything too. And this communication used as analog signals. Analog signals, that is the first generation analog signals, 1G. Agreed? So it is only mostly data, and there were actually, if you say 1G, 2G, is there no 1.1, is there no 1.5? Yes, there are 1.1, 1.5. Actually, SMS came near 1.5. So there is SMS in 1G, but it's 1.5G. Okay, you don't need to take it particularly like that. So that is the first generation of phones. Actually in Europe, it all started in Europe, Sweden or somewhere, I forgot that. So they all, 1G was started there. And then even Motorola phones were the first phones, I think, who started this 1G also here. And then Qualcomm, do you know Qualcomm? It is in Sunnyvale, San Diego? San Diego, yeah, it is also in Sunnyvale. They are one of the primary ones who created some technologies like CDMA and really 2G. They really worked hard on 2G. Really, so this is one of the company which really strengthened the 2G and the CDMA and all this thing. 2G is moving from analog signals to digital signals. 2G, second generation, is nothing but network. I am not talking about phones here. It's not your iPhone 3, iPhone 4 here. Okay. So 2G means like it's all about digital. There were three technologies evolved when we went into digital. One is called GSM, one is called CDMA, one is called TDMA. What is this GSM? What is this CDMA? What is this TDMA? GSM is like global, it's a Swedish name actually. If you go for this one is called Group Special Mobile, or it's also called as like Global System for Mobile Communication. Most of our phones which we use GSM communications. GSM is nothing but it uses SIM. It uses SIM, and inside it uses TDMA sometimes to enhance it. Okay, it is one of the first digital kind of stuff. Okay, I will tell you what is the difference between TDMA and CDMA. Okay, so GSM is first was actually it was created in Sweden and it became most popular because it's a subscriber model. You put a SIM, you connect to it, you remove the SIM, you are done with it. You can have dual SIM, you can have 4 SIMs. Yeah, I saw recently iPhone 5 with 2 SIMs in India. Yes. So it's all GSM. That is the beauty of GSM, subscriber model. Then there is CDMA. See, it's all about how you multiplex your radio signal. See, what we want from mobile phones day by day. For example, what do you want in your next generation of your network? Can you tell me what is the first thing everyone wants? More speed, more data. That is what everyone wants. If it is in the same frequency, how can they increase the data? They multiply a frequency by channels. See, for example, I am sending you at a frequency. So if I press a key, I will say, remember, even frequencies, these radio signals were there from long time. If I press one key, I will send a radio signal that is like, one, you can say another one is this one. So if there is a single frequency, if I am given a single frequency, I can send some data. But if you are asking me on the same frequency at a time, like, okay, 1 GB of video or something, how can I send it? I can't go for other frequencies. Because all the frequencies are taken by other people, it's costly for me. Agreed? And it means generally people don't get that many frequencies because it's limited by government and everything. Like there are many other governing bodies to take care of that. You multiplex that frequency into channels. So I will send using multiple channels. So this channeling, this multiplexing, I can divide by data complexity, or I can divide by time interval, or I can divide by something else. I forgot that. Any electronics student here? So, you same frequency signal, it can become multi-signal by multiplexing. Means there is a single line. Think like there is a wire. Agreed? I am sending you something over the wire. One by one will come. Agreed? But if I want to send more stuff, I multiply them into channels. Each, the wire into multiple channels. Agreed? And I will send something in each channel. And at the receiver, you will combine them. So this division, this multiplexing is based on different. I can do time multiplexing. I can do, I don't know. There is complex division multiplexing. Means you will depend upon the data and everything, size and everything. So I can do those kind of multiplexings. Yeah, Sanchita, and remember, these are all generations. We are not really doing mobile testing here. We need to move on. The reason is, uh, this is to give an idea only, to introduce you mobile concept. But we don't want to spend much time here. The reason is, no one will ask you what is CDMA because you are not going as an electronic engineer there. Okay, you can tell that we supported GSM, CDM, and all this stuff. Okay, the next thing. So 2G was all about that. Some people took like some carriers took CDMA, some carriers took GSM, some carriers took GSM plus TDMA. Combination of these technologies, network, and recently the network speeds are increasing. Remember, network speeds are increasing. So actually, most people are moving to this WCDMA rather than GSM because it is more high bandwidth. You can use high bandwidth using that. Okay. Later, there is 2.5G. And another thing with 2G is you can send SMS, you can send, MMS also, you can send data also. But the data was at very low rate. The data, you transfer the data at very low rate. And data goes into different channel, voice goes into different channel. Am I clear? Because you can still talk on the phone, you can still get SMS. Agreed? It's agreed. So these are the things like that was at very low rate, and now 2.5G it increased the rates. There is a technology called Edge. Let's go to Edge. Edge is nothing but improving the GSM, like it's increasing the speed of GSM. So it's nothing but latest of GSM. But actually the Edge also didn't survive after that because 3G 4G came. I will tell you what is that. Okay, then there is 3G. 3G is all about internet, because if you want to use internet, you need higher rates. Agree? You need higher rates of data. So carriers moved to CDMA technology because CDMA was offering high bandwidth of data. Okay, so this is all 3G. So you can do video, you can do surfing, internet and everything. So that is all about 3G. CDMA, complex division multiplexing. I forgot what is it. Okay, all right. Okay, if you see here the rates of the speed, so this is voice only. This is 2G has data also, but 56 kbps to 115 kbps. 3G 5.8 mbps to 14.4 mbps. You see that? Then 4G it's 100 mbps. Agree? So it's 100 mbps. That is one thing. And then now it is 4G LTE. Actually, some people say 4G LTE. Now actually 5G is coming up too. Okay. All right. So let's go for the technologies in 3G. Actually, so 3G. There are everyone is moving to CDMA. CDMA is not about how you use your phone, how the frequency is received, how the frequency is communicated. Am I clear? All these networks are all about. What is 4S? iPhone 4S is a model of iPhone. It's not G. It's not. I am not talking about phones here. I am talking about networks here. Alright? Yeah. 4S is 4 with Siri. Okay, let's not talk about iPhone here. We are not here to learn iPhone. Okay? Yeah. Yeah, coming back. So 3G, see, remember, first generation analog signal, second generation digital signal, third generation high speed with data, means like high speed of data. So you can watch internet and you can, most of the networks still actually here, still some of them are 3G, some move to 4G. So it depends on your location and area, all this kind of stuff too. So 4G, what is about 4G? 4G is all about very high speed and it's IP based. So there are some technologies which came in 4G. What is that? LTE. That is called a long-term evolution. And there is something called WiMAX, worldwide interoperability of microwave access. And then something called a HSPA. So people will use combinations of this one. People will use, what are these technologies? These are the technologies which will make your frequency more faster. Agree? Frequency, for example, there are multiple, again, more divisions in the frequency, more data, more speed. Am I clear? Okay. So these are updates done to nowadays. See, all are based on CDMA technology. Means how they do it and bring another technology is different. But you know, it's all about multiplexing. Okay. So is this has anything to do by Wi-Fi, Bluetooth or anything? No. This is all about mobile networks. How frequencies are used or how frequencies are multiplexed within a mobile network. Okay. Remember simple thing. There is a single line of communication link, a radio signal link between your phone and the tower or whatever it is. Using the single line, how can we get multiple things? You can play the audio, you can play the, you can still go for you can still talk on phone, you can still send a text message, so you can still browse. Agreed? So your data is multiplexed, multiplied into different channels over the same frequency. Agreed? So the number of channels are increasing day by day. That's it. Okay? Am I clear? Alright. So that is all about, see, it doesn't have to be a smartphone. Even on your Nokia phone or whatever the old phone, Motorola phone or anything, you can still go and let's say, you can still go and say you can do text message at the same time, you can still be on a phone call with someone. Agree? It doesn't have to be a smartphone. What is smartphone? Apps and everything. So was there not an app in the Nokia phone or Motorola phone before? Was there no app at all? There were games, right? You could play something on your mobile phone, Samsung phone and everything. What is smartphone then? What is smartphone? What is smartphone, please? Touch screen, GPS, compass, and let's say gyroscope, accelerometer, and please bring it up. Multitasking, very good. Yeah, multitasking. More. Programs, like multiple programs running. Yeah, programs. Pictures, camera, video camera, Bluetooth communication, near field communication. Touchscreen is all about user friendly again. Browsers, very powerful browsers. Very good. Bring it up. Open your phone. Yeah, apps are all, yeah, I discussed that. Means I don't want number of apps or anything. I want what is inside the phone. What you want to use from the phone is different. What is inside the phone? All the types of Wi-Fi receiver is there. Bluetooth receiver is there. NFC receiver is there. Agreed? It supports all the protocols, HTTP, SMTP, IMAP and all this. Sky scanner, what is that? I have no idea about it. It's camera, right? If it is something scanning means camera. See, how you use the camera is up to you. Phone gives you camera. App is built by someone else. Am I clear? Agreed? What phone gives is more important. Infrared. You can control your TV, Roku and everything from your phone. Infrared. Proximity sensors. So if you come closer to it, if you put closer to your cheek or something, light will go down, Sensors. Yeah, sensors. Light is one of the thing. Yeah. So these are the things. So how does a smartphone work? Now coming back, if there is a smartphone like this, how does a smartphone work? First thing is touch screen. Touch screen. How does a touch screen work? If I press something on the screen, how does the app opens? Tell me that. What is that concept called? Infrared grid. That is called infrared grid. Over the screen, there is a grid of infrared. So if you press that grid, it knows where on the grid. So this screen is divided into a grid. It's nothing but boxes. Okay, let me show you. I can't draw everything. Okay. The reason why I am explaining all this, do you understand? Because I don't want you to speak about touchscreen tomorrow. I want to speak about infrared grid tomorrow. The language you use to other person should be different from a common person to you. Am I clear? Alright. For example, this is your screen. This is divided into like a grid. Small, small, small. That is, each one is called a pixel. Remember? A grid. And this grid will be there. And if I press my hand here, like if I press my, for example, let's say, if I press my finger here, not hand, it knows that I'm pressing at that grid and it will take it to the program. He pressed at this location. It knows that what is the icon at that location and it will open that application. It's a communication between infrared grid and everything. Alright, very good. So how does, if I rotate it, how does it will change its screen, what is that called? Movement and everything, how does it do? So if I tilt it, how does it change everything? Tell me that. Anyone? Come on. We are all smartphone geeks, right? Very good. Very good, Rani. There is a company called Intelligence. They started in 2005. They become very rich in next year itself because they created this. They create for Wii game and iPhone, Android and everything. Okay. This is called a gyroscope. Do you see that gyroscope? If you tilt this machine, do you know can you tell how it tilted? Because there is a x-axis, y-axis and z-axis. If this circles change, it knows that, oh, I am turned to right. If it change, like this is x-axis, sorry, this is y-axis, x-axis, z-axis. Do you see that? It's circulating like this. It's circulating like this. So if you tilt this anyway, this can find the rotation angle, how much you tilted me and which side you tilted me. And this is a normal gyroscope. And someone created this inside a chip. And that company is called Intelligence and they became famous. They became billionaires actually. Okay. They are in Sunnyvale. Agree? Okay. Alright. So this gyroscope is put into a chip, small chip, and you can't even see that. So that is how the tilt will know, and this will be given to the program. The hardware will tell the software that, I have been tilted this much angle, and software will know that, oh, you are using a YouTube in this angle, let me move to this angle. Understood? For example, for example, there is accelerometer. For example, if you press from, if you do, what is that called? Snap, or, you flip it off, you flip pages, you hold on to an icon and drag it to somewhere. How is that happening? There is something called accelerometer. How much pressure you are putting on me? How much pressure you are putting on me? That is called accelerometer, which takes care of all this. Agree? So what are the components inside a smartphone? There is an infrared grid. There is a gyroscope. There is an accelerometer. Okay, these are the main components. So all this Wi-Fi receiver, all other things like, phone receiver and all these are common. Agree? We don't have to, those are nothing special to mobile phones itself. Bluetooth receiver. Agree? So we don't have to, for example, sometimes they might have USB receiver also, mini USB. Agree? So these are not, and proximity sensors, there will be sensors. If you come close to the sensor, it knows that, okay, you are close, let me turn off the light. Okay, those are proximity sensors. Okay, are we good? Alright, it's not mobile testing, this is more about how to use phones. Yeah. So what are the services mobile phones give us? Cellular, you can talk on phone. Bluetooth, you can connect to other devices. Wi-Fi, you can connect to internet and router at your home. GPS, you can get location services. You can find where is a restaurant, close to my location and something. So you can have maps also. Camera, agreed? You can take pictures and you can take scans and all this kind of stuff. And you can have a video camera, agreed? You can have speech recognition, agreed? You can have a voice recorder. You can have a music player. You can have near field communication. You can use it like a PDA, contacts and all this is like a PDA, personal digital assistant. Agree? Notes, taking notes and everything. And browser is there. I don't have to tell you that. So these are the services which mobile phones gives us. Am I clear? Okay, next. What are the mobile smartphone operating systems? Let's look at the smartphone operating systems like our mobile operating systems. Android is by Google. Actually, it was started by Android Inc. and it was taken over by Google, and it is a open source project by Open Handset Alliance. I will talk about that later. Everyone knows Android. Okay. There is BlackBerry. BlackBerry is by a company, some Canadian company, RIM, R-I-M, RIM. It's from a Canadian company. Alright. And iOS is by Apple. S40, S50, S60. This is Series 40, Series 50, Series 60 by Nokia. Your Nokia phones have your S40, S50, S60. Windows C used to be an old operating system of Windows. Like for example, remember even like 10 years, 15 years back, if you go to a warehouse, people used to scan and get all this information on that. For example, people can scan an item in the warehouses. That is our mobile phones too. Those used to use Windows CE at that time. Means Microsoft always actually started making mistakes after 96. It never thought internet will be a big hit. Browsers took over, okay, and it never thought that mobile phones will be, it was the first one to create all this. It was the first one to create a mobile operating system, to be honest with you. But it never saw that it should be used for personal usage. Remember, IBM made the same mistake at Windows time. Microsoft is making the same mistakes now at internet and mobile phones time. Okay, alright, let's forget about that. Let's not get personal into companies. Okay. And then Windows created Windows Phone. Remember Windows 5, Windows 6, Windows 5, Windows 6, Windows 7 was the last, and Windows 8 is different. And Windows 8 is the new mobile Windows OS. Agreed? Yeah. So, and there is Brew. Qualcomm created Brew. Brew is something like which used to be in old devices. It's a operating system. So let me show you a picture. See, these kind of things, it's better to clear it up with a picture. Agreed? Let's say a Brew. Oh yes, see. Yeah, not this one. I will show you. Not this one. This is all Android. Brew OS home screen. Yeah, the basic, this is one of the Brew type, but it used to be very, maybe this is one of the latest Brew, but it used to be before. So this is a, for example, you can think like your Samsung before this flip phones used to be famous, right? I don't know what is that flip phone. Remember? Yeah, Galaxy or something. Not Galaxy. Remember, like they used to be very famous, like around 2006, 2007, or 2005. Okay, I forgot those. Okay, they used to have Brew. All right, Kamal, can you hear me now? Kamal, can you hear me? Yeah, all right. Can you speak up, Kamal? Sorry, can you just type that you hear? Ramani, I am not sure about the other session, but I am taking this session. And I am the only one who is taking this session. Okay, all right. Coming back. So forget about Brew. There is Bada from Samsung. Samsung phones used to have that. Okay, and Symbian OS. This is the largest OS until Android beat it. All the Nokia and everything used to have Symbian OS. All your games, like those games. Remember the famous games, Bubble Breaker. All these kind of games are Symbian OS. Okay, so it is the largest OS. Like, no, sorry, Raman, I didn't mean anything. No. I was just kidding with you. So actually, like, I don't know if there is any resume session going on, because I don't check my emails when I'm in class. Do not worry about it. Yeah. So Symbian OS is the largest operating system, because see, don't consider only US. Think there is a huge market in Asia, Japan, China, India. There is, like, if you consider the number of people using that OS used to be huge, and Android beat it in 2010. Okay, all right. And there is WebOS, HP. Remember, we got HP phones free sometime, like HP gadgets. They say sold all of clearance sale, like 1 year back or anything. Okay, $99. That was the last of WebOS. That was the end of WebOS at that time. Okay, yeah, tablet. Yes. Okay, that was the end of that OS. Yeah, because they didn't support it, that OS for. Really? Okay. No. Okay. Okay, let's wait then. All right. So Ramani, actually there will be another Saturday mobile testing session from me, and there will be a Shilpi session on how to do Android testing specially. Okay. Yeah. So coming back, so you know that there are this many operating systems. So people will ask you, how many operating systems you know in mobile phones? I know, like BlackBerry, iOS, S40, S60, Bada, Blue, and everything. But what did you really test? Do you want to go into old, or do you want to tell what is new? Android or iOS? And 90% of you will tell that I only worked on Android application. For example, if a company has 3-4 applications, it will be different teams. iOS will be given to one team, Android will be given to one team. Okay, remember that. So even though you know all of this, you have an idea about all of this, but the one you are testing is mostly Android. And again, you don't have to tell that I tested a application for Android for US only. For Hong Kong you can test it, for Japan you can test it, for China you can test it, for example, all the development is done here only, software development. Means at least the management and everything. So you don't have to just bring an application which US is using only. You can just randomly tell this application is for Hong Kong users. Simple. Done. Okay. Understood? So mobile is vast. You can take it anywhere you want. Am I clear? Okay. Alright. Please remember these points. Okay, I'll repeat this again. Remember, you have to tell Android only. 90% of the time you have to tell that you are testing Android only. And you don't have to tell that app belongs to US category. It can be Hong Kong, it can be Japan. I know recently someone who worked in PayPal for Japan thing. PayPal for Japan. Yeah, so remember I showed the test cases. Simple, you need to come with this kind of scenarios. Agreed? Because they are safe. Yeah. So these are the operating systems. Okay, so let's go. There is always this difference. Native app, mobile app. For example, there is Google, Gmail, iPhone app. Is there a Gmail iPhone app? Gmail iPhone app? Gmail iPhone app. Is there a Gmail iPhone app? Of course it is there. Is there a Gmail Android app? Yes, it is there. Right? There is a Gmail, for example. Didn't you see this kind of app anytime? For example, let's forget about that. Is there a Google Maps iPhone app? Okay, all right. Or let's say Facebook. I think this will be very, very good for you. Okay. Yeah. So, yeah. So, is there a Facebook app for iPhone? App. I'm saying app. Can you go to mobile browser, open on Google Chrome, and can you do facebook.com still? Can you still log in? Can you still type from there, chat from there? Can you still do all this kind of stuff? So that is called, one is called mobile native app. When you click the button of a Facebook app and the screens and everything is called a Facebook app, native app. If you go to browser and do facebook.com, that is called Facebook mobile app, mobile web app, web application. Agreed? So there are two things. One is installed, yeah, native apps and web apps. Yeah, please. Thank you. Alright. So native app, let's say native app. This is native app. Okay, this is native app. And Facebook web app. Let's see Facebook web app. This is native app. Facebook web app. I can't see it here, but you understood. Yeah, this is in web app. See, this is a browser. Agreed? And the app is, I am accessing the web application here. I open a browser and I access the web application there. This is, I directly click the icon. Agreed? This is, I directly click the icon and it will, see, this is like the Facebook app, right? So everyone understood what is a mobile native app, mobile web app. Agreed? So is mobile web app for Facebook is the same as the desktop web app? Okay, so let me write it down. Mobile web app, native app, mobile web app, web app. So is mobile web app and there is desktop web app. Agreed? Please everyone go to your phone once. Open the Facebook app and go to browser and open the facebook.com. You understood, right? What I'm saying? If you do facebook.com from mobile web, facebook.com, is it same as if you go to your desktop and do facebook.com? Is it same as, is it same? Means the screen is same? Is the screen look same? No. Why? Remember, there are two things. See, when you are making mobile applications, there are two things or many things actually you need to remember. Screen resolution. You can't pass all the HTML should be less because it's data, it's your money, right? People don't want huge data. Agreed? So less data. We need to pass less data. Another thing is resolution. We can't see more. And it should be clickable. It should be because you use hand. You can't have small links like 100 links. How will you do that? You hate that site. It should be less icons and links, less icons, buttons and links. Agreed? So when you make a web application, for example, if you go to google.com, this will be like that. If you open it from a mobile web, it will be m.google.com. Agreed? It will be m.google.com, m.facebook.com or m.gmail.com. Do you see that? So the web application for mobile is different. The web application of desktop is different. And native apps are different. Which one is better on mobile phone? So on coming to mobile phone, which one is better? Native app is better. Why is it better? It's very easy. So you don't have to type a lot. Yes, you don't have to type a lot. First thing is, next thing, yeah, just click open. You don't have to type a, you don't have to click URLs and all this kind of stuff. And it is specifically designed, that app is designed. It can use everything built into iPhone. The second thing, for example, you can use your contacts in the Facebook. For example, search who is on Facebook using your contacts. Remember? For example, you can integrate the maps into Facebook. You can open one app from another app. You can go back, means you can use the features of other apps and the complete smartphone functionality from that app if it is a native app. Agreed? User friendly. Okay, let's go and see. So that is one thing. And the next thing is, it is built for specific operating system. The features for Android are different. The features for iOS is different. Is there a back button on Android? Sorry, iPhone. Is there a back button on iPhone? Is there a back button on iPhone? Where is the back button on iPhone? On the phone I am asking, I am not asking on the app. On the phone. Is there a back button on Android? On the phone itself is there. So every app should support it. Every app should support it. Sometimes there is no going back in iOS. You have to go forward using buttons. But there is always going back in Android. Agreed? That is by default functionality. You see that? So people will ask you differences between iOS and Android. This is one of them. So similar. So when a developer is making a Gmail app for Android, he needs to make functionality for back button. But when he is making for iOS, he needs to make everything inside the app. Do you see that? Agreed? So native apps uses notifications. You can use notifications, Facebook notifications on the phone. Can a mobile app give you notifications? No. Agreed? So and native apps use the real-time web connectivity. If you are not connected to internet, can you open the app? Can you log into Facebook? But for example, on a mobile app, you open the Facebook, you are in a page, you still have that screen. You still have that screen, right? You can still minimize, the screen is still there because its HTML is loaded onto your machine. App won't load anything until you connect to the server. That is the difference between app and HTML. Remember that? Okay. HTML is loaded onto your local machine, local phone. So HTML is still there. You can have the screenshot and everything again. But app, if you don't have internet, you can't open. It's a real-time connectivity. Like this is not real-time connectivity. You connect, get it, stay there. But for app, every time if you want to go to the screen, every time you are using your data. Do you see that? Data is more consumed in apps than HTML. See, maybe you'll switch to HTML now. Because it came, we received it. We received it. Once we receive HTML, it's on our browser. Unless you close the browser, it's okay. Agreed? But the beauty is, developers doesn't have to build a mobile web application for Android, iPhone and everything. They build it for Chrome browser, they build it for Firefox browser, they build it for Safari. And most browsers are same. They don't have to build it for even specific browser. If you make a mobile web application, it is same for all the phones. Agreed? But if you make a mobile native application, is it same for all of the operating systems? No. You have to make it for Netflix for iOS is different, Netflix for Android is different, Netflix for Windows is different, Netflix for Roku is different. Agreed? So these are different. Means developer needs to make an app for each one of this. But mobile web application developer doesn't have to do that. Am I clear? HTML is HTML. You give HTML, every browser will show HTML. Agreed? Native apps are usually fast and polished. They can use the graphics and everything of your mobile phone. Agreed? They can have all the colors and everything, but mobile web applications, no, because they are inside a browser. Okay? And can you play a game in mobile web? Or can you play a game in mobile native app? Would you like to open Google Chrome in your iPhone and play a game? Or would you just click the app and play the game? App is performance. That is what I'm telling. High performance is from native apps, not from mobile web apps. Agree? Sirisha is asking, most of the mobile testing is native apps testing. I am not saying that. It depends on your application. Okay. Yeah. Another fundamental advantage is, one second, native apps use real-time connected misconception. Yeah. People, see, right now I just told one thing. Native apps can use like notifications and all these kind of things from your phone. For example, they can use your Siri functionality, they can use your contacts functionality, they can use your GPS screenshot. For example, Bank of America says that take a screenshot and deposit the check. You don't have to go to the bank. So they are using the camera functionality in the phone. Can a mobile web application do that? Can a mobile web application do that? No. If you use m.bankofamerica.com, can you do that remote deposit? But actually now W3 is saying you have to support it, otherwise it's not compliant. So nowadays they are moving to that. Mobile web application should also look like app. Okay, mobile web application should also look like app. Okay, we will come there very soon, not right away. Okay, yeah. Another thing is security, which is more secure. For example, mobile native apps is more secure because it can use the underlying security of your application architecture of that phone. Alright, very good. So when you have something in mobile phones, there is a mobile application. There is a mobile application. What are the things you need to test in mobile application? Of course, everyone should test functionality. I agree. If you are not testing functionality, then that is something crazy even after all these classes. Agreed? So, mobile phone, especially what are the things to test only specific to mobile phones? This list is little. This will be improving over the while. Means I didn't add much because I only thought of you now. Because I am not really testing mobile phones or I didn't do this before. So that is the reason. This list will be growing. Screen resolution. Now if you open Bank of America on iPad, iPhone, mini iPad, iPod touch, agreed? Resolutions are different. iPhone 5 resolution is different. iPhone 4 resolution you have to test for each resolution. Agreed? You have to test it for each resolution. Okay. Screen orientation. Screen orientation means every mobile phone has this following features. Actually, smartphone means there are some following features. I will tell you 1 second. I missed this. Where is that? One second. I missed something. Yeah. Yeah. On every phone, you can do this following things. Let's see what does this mean. Tap. What is tap? Single click. You can do double tap. You can do double tap. What is press? If you go and press on that icon for a while, it will ask you to remove that icon. Remember, remove the tab. That is called press. Scroll. You can, move your finger from top to down or this kind of stuff. What is pan? You can do pan. Press it and move it. Press it and move it is called pan. These are common for all the phones. Remember, these features are not just for iPhone only or your Android phone only. Common for all the mobile operating systems should support these gestures. These are called gestures. Tap, double tap, press, scroll, pan, pinch. Pinch means, remember, you zoom it out. You are reading a book, you want to zoom it out. And reverse pinch means you make it small again. Flick it if you are doing ebooks or anything, like iBooks or anything, like, just do flick it at the end, the page will turn over. Rotate. You can rotate it when you are doing games. Okay. Rotate it, you are doing games. Tilt and everything are gyroscope functionality. Tilt and everything. That is not screen functionality. Okay. Tilting. So you have to test on every screen that what do this gesture do. Am I right? Screen orientation. What if I tilt it? What if I do pan on it? What if I do press on it? What if I do, what will happen? You need to try it. Agreed? For every screen. Flipboard, okay. Alright. Load UI, okay. Next thing is, see, why are mobile phone screens small? And see, the biggest problem industry is facing is battery life. That is the biggest problem. You need to charge. That is what you hate it. Right? No one can give you like limitless, So that is the biggest problem. That is, resources are very limited. If you open 10 apps and if you don't kill them or if they don't stop using resources, your battery will die soon. So building a mobile phone is all about making this resource, CPU and network consumption. If you, for example, if you minimize Bank of America, it should stop using data. It should stop using your network. It should stop using your CPU. It should stop using your RAM. Am I clear? Otherwise your phone will die soon. That is the first thing everyone should test it. because resources are limited. Otherwise they will give you big huge browsers also. Why they are giving you limited browsers, limited HTML, limited, limited functionality, because of this battery, because we don't have, if I keep on using it, even if you turn the iPhone on or your pad or phone on, it will die soon, because the light itself takes, means this grid, how this grid is working and everything, this itself takes consumption. Even without doing, if you turn on the screen on without, and with high brightness, it will die soon. So battery is the biggest problem. So limited consumption. There should be bar lines when you are testing this one. I cannot consume more than this CPU. I cannot consume more than this data. Agreed? Yes, there is a button you can stop running apps, but what I am trying to tell, when you are doing, for example, Bank of America transfer, if it gives me 400 bill, do you do transfer from Bank of America again? Simple. The app will die. Great, the app will die. So it's better to, means even when the app is running, we need to make sure the CPU, the network usage, data usage, because it's money. Again, it's extra money, not money. Right? So that is the reason we need to be very. Then there is something called field-based testing. This is a really important testing. Field-based testing means you want to test the app on Wi-Fi. You want to test the app on 1G, 2G, 3G network. You want to test an app with 1 bar signal, 2 bar signal, 3 bar signal, 4 bar signal. You understood, right? Capacity of the signal. You want to test that, okay, there is a small link happening, but like you think like limited, so you want to create scenarios that, you need to simulate network scenarios. You need to simulate Wi-Fi scenarios. You need to simulate all the kinds of scenarios for field-based testing. That is called field. Network, Wi-Fi, Bluetooth, all these are called field-based testing. Agree? You should also test multitasking. Means, for example, I want to open my Bank of America while I am listening to songs. Agreed? A song is playing on the background. I want to do still Bank of America transaction. How it will be? Agreed? So multitasking functionality also, you need to make sure that the multitasking functionality is going through. Then there is something called weighted device platform matrix. Wow. What is this weighted? See, for example, I want to test, for example, Bank of America. Just take iOS as the case. Okay. What is this? Weighted device platform. Okay. What is this? I want to take just on iOS. You take a device, let's say iPhone 4S. Okay, iPhone 4S device. What are the operating systems iPhone 4S supports? 4, 5, 6. Agreed? So, you have to test Bank of America with iPhone 4S with operating system 4 version, with operating system 5 version, operating system 6 version. You have to test iPhone 5 with 5 version, 6 version. Do you see this? And iPhone 3, still many people are using iPhone 3, iPhone 2 also. You have to test everything. So there is a matrix on how many devices, how many versions of the apps. Agree? So that is called matrix. So you will create a matrix. Let's say, I will give you a simple example. So this requirement traceability matrix, right? Just like that you will make a matrix here. Okay. Let's say this is for example, our app supports iOS 4, iOS 5, iOS 6. Agreed? And what are the devices? iPhone 4, 4S, iPhone 5. Agree? I have to test this for this one. I have to test this for. I cannot test this one here. I don't know if iPhone 5 supports iOS 4. I'm just thinking that it doesn't. You see, these are the combinations I need to test my Bank of America applications on. Yes, very good. Okay. All right. So now you understood what is this matrix. This is for iOS because Apple only and again, not only iPhone, iPod Touch, iPad. You have to do for Apple TV. Agreed? All the devices also. It's a device. Operating system version. Agreed? Device version. Device version, operating system version, app version. The combination of all these things you have to test it. Am I clear? Like browser matrix testing, this is also agreed. So you have to see simple. This is good for IC because at least iOS is supported by Apple only. No one in iPhone can you load anything else? No. Yes, you can't do that. You can try to do that, but you can't do it legally. So means can you load iOS and any other device? No. But what about Android? Different companies, different operating systems, different versions. Agreed? Different versions, different handsets, different company handsets. So there is endless limits of like matrix there. Agreed? You have to test with HTC, Samsung, Motorola, Nexus, Asus, all these kind of combinations of devices, tablet, phone. Android is even supported on wristwatch also. Okay? So these are the combinations you need to test. Okay? Alright. So that is called, what is that called? Weighted device platform matrix. And performance. You need to test the performance. How much RAM it is consuming, how much processor time it is consuming. Compatibility. Browser compatibility. Operating system compatibility. Device compatibility. Okay. Usability. How usable it is. How it looks. Look and feel. The buttons are small or widgets and all this kind of stuff. Yes, you can use JMeter if it is Android. Directly from Java. You can use JMeter for Android. JMeter is good. How to connect is bad, but JMeter is good. You can't use load runner. You can't record. First of all, recording itself consumes energy there. Okay. Alright. Okay, coming back, let's come to operating systems. Yeah. So I know I have discussed Android and everything, but now let's go to see really see what is iOS. Let's see what is Android, and let's go into Android. Okay. Yeah. Alright. What is the latest version of iOS? Now we are talking about iOS 6.2.1 or something. They fixed a bug in Wi-Fi or something. Not Wi-Fi, somewhere in yeah. Okay, so you can read that actually. Remember, who created iOS? Apple. What are the devices supported by iOS? What are the devices supported by iOS? iPhone, iPod Touch, iPad, iPad Mini, Apple TV. These are the devices which are supported by iOS. Is there any other device? No. How do you get your apps from? There is an app store. Agreed? There is an app store. What is the language developers use to make apps? Objective-C. Object-oriented C. Agreed? What is the real C? Actually, iOS is nothing but the cut down version of OS X. Mac OS. Does anyone know Mac OS X? So iOS is nothing but the cut down version of Mac OS X, not S. Okay. Mac OS X is based on Darwin POSIX, Unix based system. It's a Unix system. So Mac OS underlying system is Darwin Unix system. That is called Darwin. It's a Unix based system. So can you go and do LS on iPhone? Can you go and do rmdir? Yes, if you really get to the access to the kernel command line, it's a Unix again. It's a Unix again. iOS is a Unix. That's what I am trying to tell. Agreed. Finally, iOS is nothing but a flavor of OS X. OS X is built on Darwin Unix system. So finally, it's a Unix system. Agreed. Or PS. Or say let's kill all. Agreed. Okay. So what are the gestures it supports? Same gestures everyone supports. Tap, press, scroll, pan, pinch, reverse pinch, flick, rotate. Okay. iOS is very strict about some things. It doesn't run Java by default. You need to jailbreak it. Okay, it doesn't run Flash, Adobe Pot with Apple. It doesn't run .NET framework. Okay, that is the thing about iOS. Can also be Linux. I don't think so because it's coming from Darwin Mac OS, so I don't think it is Linux. You can't say Mac is Linux. Mac is Mac, Linux is Linux. Okay, all right. Okay. What are the versions of iPhone or sorry iOS? We are not talking about iPhone here, we are talking about iOS here. Okay, there is a difference. 1.0 first phone was released 2007 I believe. 2.0 okay, some features were developed. 3.0, 3.2.2 iPad came. 4.0 multitasking came into picture. Of course it is not really multitasking, there is still not 100% multitasking in Apple. Okay, so that is the reason it is going little bit down. I am not saying it is completely going down, that is one reason which it lacks. Okay, folders came up in 4.0, so many features came up in 4.0. really actually 4.0 is a major revision of iOS. Agreed. 5.0 like in 4 point somewhere actually Apple TV was supported, and iCloud, iMessage, newsstand, notifications was redesigned. Okay, and 6.0 they created their own map so that people can get lost. Remember, they removed the Google Maps and they created their own map so that you can get lost anywhere. It will be interesting so that, and they created the passbook. Thank you, Anu. Yeah, so, and remember, everyone should go and read this iOS version history from Wikipedia. You'll know what is the difference between iOS and 1.0, 2. Yeah, so 1.0, 2.0, 3.0 and everything. Okay, so you should go and read that. So any questions here, please? I see some strange faces and yeah. So tell me any questions here. Everyone should know what is the difference. Okay, people will ask you what is the latest operating system version you are using in. Oh, I am testing on 4.0, 5.0 and 6.0 because we have to do that weighted, what is that, weighted device matrix platform matrix, so we have to do on 4, 5.0, 6.0. Oh, very good, that's it. Okay, so everyone should go and read this link. You should use it in your resume notes. Yeah, I know about iOS maps. Yeah, okay. Alright, some features about what is iOS. So when you are talking about iOS, what are the features generally you see in iOS? There is a home screen, everyone knows, that is called Springboard. You should tell Springboard, you should not tell home screen, please. Okay, that is Springboard. There is a spotlight search. If you do left click on the home screen, it will go to a search thing, right? That is called spotlight search. It will search your mail, it will search your apps, it will search everything. Agreed? You can have the settings for this in settings. Means what to search, what not to search, you can put that. That is called spotlight. So Springboard, spotlight. You can have folders. Agreed? So when you are testing an app, you should put it in a folder, remove from a folder. Do you see that? When you are testing an app, you are testing about the folders also. Notification center. For example, for Gmail, you want notifications. For Bank of America, you want notifications or you don't want notifications. Where will you go? You'll go to settings, notifications, and you'll click on the app. I want notifications, I don't want notifications. Agreed? Or I want notifications for this only. And there is basic phone functionality, don't forget that. Maybe sometimes in 4S or 5, the signal was very weak, but it's okay. We still had phone. And mail, we still have mail. Okay. So it's still suppose you can add Gmail, but with some complexity. And we have great Safari browser. Okay, which nowadays everyone moved to Chrome. And we have music there. Of course, we cannot forget iTunes. Okay, and there is videos there, which we were always using YouTube, but now they forced us to use another videos, but we still go back to YouTube. Yeah, we can use that. I'm just kidding here. See, I'm not against iOS or anything. So I'm just trying to make it interesting for you. That's it. And messages is there. Finally, we got iMessages. Agreed? After a long time, after we have been using other messages like yeah, Viber and everything. So we finally got iMessages. Yeah. And we got photos, and we can, I don't know if we still can take panoramic photos or not, but we can take photos. We can take photos. Yeah. Yeah, we can take videos too. And then we can do FaceTime. Yeah, but still most of us use Skype. And then we can do notes. And then we have the great maps again. And we have contact list. Sometimes they are not integrated well into other apps. We can't find a contact sometimes. And especially, did you search in mail, iPhone mail? If you search something, it will give you something else. That if you search for something, it will give you something in 11, 20, 2010, 2009, the latest one. If I search for yesterday's email, it will give me 2012 email. Yeah. And that has been there from a long time. And then there is iTunes. They are changing the look, but not the functionality. There is App Store. Yes, we can get charged for that. And there is Siri. I still don't know how it is still working. And there is Passbook. I don't know if anyone used that. Passbook is like a wallet. You can put all your credit card information, apps on that. So you can directly pay from your passbook. Passbook is like your wallet. Okay. And there is Compass, which sometimes works. Okay. Okay. Is it? Say it again. In photos, there's one thing called photo stream. Photo stream means you can pass. See, for example, if you have an iPhone, I have an iPhone. If you have an iCloud account, you can share me that your photo stream. Means you can share me live whatever you are taking. So you are sharing between your using iCloud to me. And there is iCloud. I forgot. That is cloud storage. Yeah. Yeah, there is iCloud. So yes, we still use Dropbox even though there is iCloud. We still use Google Drive, SkyDrive, and Dropbox. Yeah. Yeah, there is a game center too. There is a newsstand too. Very good. Yeah, newsstand to put all your magazines and everything. Okay. Yeah. All right. Coming back. So Anu is asking me which phone you have. I like Apple hardware, Android OS. I like hardware of Apple and software of Google. Okay, understood, right? I am not getting a combination of that. Yeah, I yeah. Yeah, the speak up. 1 second. I can't unmute you on. Maybe it was intentional, not intentional, but oh, you need to type it there. Okay. Yeah. So all the companies which do Android hardware are not really up to mark. So Samsung tries a lot, but and the one thing I really hate about is Nokia going to Windows 8. Nokia is a very good hardware. It went for Windows 8. Yeah, that is, yeah. So it should have come to Android. Yeah, it's okay, no problem. So there is a multitasking feature. If you double click this home screen, you'll come to this multitasking. You can kill your apps here. Sometimes apps are running in the background. Mostly iOS won't run, but sometimes there might be a chance. So you can kill your apps here. Okay. What are the apps which generally run in background in iOS? Not every app can run in background. If you minimize an app, it almost died only. It almost died. You can't. It is not running. So what are the apps which run in the background? Music, VoIP, notifications, newsstand, external accessory like Bluetooth and everything. External access, USB, not USB, any, like whatever you connect to from iPhone or anything. Yeah, and there is Bluetooth also. Okay, there is Bluetooth which works multitasking, means you can still do Bluetooth to something and you can still check your mail and everything. Agreed? All other apps don't do multitasking. If you minimize, it's gone. Agreed? If you press the home button, it's gone. You can switch between apps. Remember, you can switch between apps by double clicking and going to the other app. Yeah. Okay. All right. Let's move on to Android now. Okay. Android was started by a company called Android itself. Google used to fund it. Actually, that person actually really ran out of money. His close friend lent him $10,000. That is famous story actually. Because he almost thought of closing the shop, but one person, his close friend, came and lended him like $10,000, and then Google came into picture, and then Google took over, and they came to Google. So it was like a story. Linux based operating system. It is a Linux based operating system. So it is still Unix. Agreed? The kernel is Linux. It is open source. Means you can take your Android, you can customize and you can load into your phone. You can load into notebooks, laptops, smartphones, iPhones, okay, actually smartphones, smart books, tablets, TVs, Google TVs, even TVs like Samsung, LG are coming up with Android inside it nowadays. Okay, they will come soon. Cameras, even like Canon and all these DSLR cameras will come with Android soon. Wristwatches, VoIP phones, tomorrow Vonage might have Android on its device too. Yeah, yes. So it's everywhere, it will come everywhere. So Android is not designed for phones only. Alright. So what is, see, Apple operating iOS goes into Apple phones only. Where does Android go into? Android was meant to be open source. Like many companies came together and made something called Open Handset Alliance. People who create hardware, people who are doing networks like AT&T, Sprint and all this, people who create hardware, people who create software, they all came together and it's a consortium, Open Handset Alliance, and it is led by Google. Okay, who makes decisions about Android? Google, not Google, all of them. All of them have a say. But it is headed by Google. So, what is the first Android phone? HTC Dream. Okay. So, Android Open Handset Alliance came up. Android had many complaints. If you remember, the bad thing about Android is, for example, if you buy a Samsung phone, you can't upgrade Android. Even though Android is running 4.2 version, you are still in 2.2, 2.3. So recently, Google started something called Android Update Alliance. And it gave that deadline. Everyone should give the latest version of Android within 18 months of its release. So Samsung cannot postpone more now. Okay. Alright, so 18 months is the deadline. So every device should get a latest upgrade of the Android within the 18 months. Okay. Android had many buttons. Remember that only had home button like iOS, but it had back button, apps button. There is home button. There used to be 4 buttons, and there used to be hard-coded buttons on the phone. Now actually there is no button on the phones and only one button, start button. Everything else is a soft button. Okay, there is no physical buttons now. Okay, because now Android goes into wristwatches and everything too. They don't need buttons on the phone. They need on the screen. Agreed? So now all are soft buttons. If you use Jelly Bean. Okay. What are the Android versions? Android versions are named against desserts. If you desert dish, like their names will be like cupcake, donut, ice cream sandwich. Agreed? Alright, so these are the names for their versions. So Android version 1.0 used to be there, 1.1 used to be there, 1.5 is called cupcake, 1.6 is called donut, 2.0 is called eclair, 2.2 is called Froyo. 2.3 is called gingerbread. 3.0 is called honeycomb. 4.0 is called ice cream sandwich. 4.1 to 4.2 is latest is called jelly bean. And I think they are working on key lime pie. Lime pie will come soon. Yeah. Agreed. So what is the latest version of Android? 4.2 jelly bean. Agreed. So everyone should say what are the versions you worked. I worked on honeycomb, ice cream sandwich and jelly bean. Agreed. And you need to go to this Wikipedia link and you should check the Android version history. Alright, that's all about so we know the difference between Android and everything. So there are many types of, and recently Google got Motorola mobile, and the biggest problem with this mobile phone vendors is they are fighting over patents. Patent fight, these are called patent wars. So recently Google got Motorola mobile, and it got like 18,000 patents with it. So it will come up with a device, I believe, very soon. Yeah. I'm not here to solve your phone problems. Okay? Yeah. Yeah, Android. See, like there are many bugs in Android too. I see more bugs will be in Android only. The reason is it's open. Simple. It's open. Everyone can do anything. Even you can go and create an app very quickly. Like, so it's open and you can load it into any device. Actually, I recently saw like an Android smartphone in India for 5,000 or 6,000 bucks, Indian rupees. Indian government created a $100 laptop or something else with Android because it's free. Android is free. Agreed? Tomorrow, actually, you will get Android onto your notebooks also, laptops also. Chromebook didn't work out well, but Android will come onto laptops also. Yeah. Yeah. All right. So let's go. Now, from now, I will be, for the rest of the class, it will be Android only. We are not talking about iOS today. We will talk in the next Saturday. I am not promising. I will try. Okay. Yeah. So what is Android? Android, let's see architecture, how to build applications for Android, how to test applications for Android. I am not talking about any tools or anything. I will explain what is inside Android. It's up to you how to explain it to your, yeah. What tools are used for mobile automation? Again, there is mobile native automation, there is mobile web automation. Mobile web automation, you can use, let's say, WebDriver. Android WebDriver is there, iPhone WebDriver is there. You can use any other, like you can, for example, for just simulation. See, for Android or anything device, you need to simulate the scenario. You can't go on to phone or do on the devices directly testing. So if there is a device, you can't do on device directly. First you need to simulate. You need to have simulators and emulators. Agreed? So first is you need to have emulator devices. Then once you have emulator devices, you can do automation testing. You can do automation testing on the code directly using the emulator, or you can do automation testing by recording on the screen and doing it. There are many ways. So you can use every phone comes with their own SDK. Software development kit to develop and test the applications. Agreed? So you can use the tools directly from their SDK, or you can go for outside tools. And when you are going for outside tools, again, web versus native. When you come to native, depending upon the operating system, for example, Monkey Runner is there. It will support iPhone and Android. There is Eggplant is there. There is, some other tools are there. Some support only iPhone, some support only Android. So there is nothing particular or nothing. See, it's not like QTP or Selenium which became popular. Agreed? People are still not really clear about mobile testing. Agreed? So sometimes, you can use WebDriver. People still like only Java testing based on Android and directly Xcode based. So people still like using SDK tools rather than going for outside tools. Am I clear? What iOS gives you is more important than outside automation tool for testing iPhone. People want who knows the SDK and the tools inside the SDK better rather than knowing monkey runner, eggplant or device anywhere or anything. Am I clear? But if you know Java, Android testing is a piece of cake. Okay, maybe a big piece. Okay. All right. So let's see. I hope you everyone can see this clear. Android at the bottom has a Linux kernel. The kernel, the core of the operating system is Linux. So if you see, there are so many things: Bluetooth driver, camera driver, keypad driver, USB driver, display driver, shared memory driver, audio drivers, binder driver, okay, and power management. All these drivers are there for the core kernel. Agree? And if you see, then there is hardware abstraction layer. There are APIs over for each hardware. For example, like graphics, audio, you need this abstraction, means it can't give you this driver directly to your Java program. Agree? You see, this is, kernel, operating system code. No one will give you. They write a abstraction layer. They give a interface. Remember, they give a base class or they give a small interface to access it. Agree? This is the abstraction layer. Interfaces are given here. From these interfaces, Android build you a library, Android library, so that you can use that functions and build the applications directly. You don't have to do anything. So for example, if you want to use anything, you have to use this library. Agreed? And Android runtime, see these core libraries, plus it will give you Dalvik virtual machine. Dalvik virtual machine. It is not Java virtual machine. Why? I see. Why can't, if Java if Android is open source, why it is not supporting Java, and why it is not supporting JVM instead of DVM? This is called Dalvik virtual machine. The reason is, what is the Java virtual machine? Everyone knows it. Please tell me. What is Java virtual machine? Converts bytecode to machine code. Very good. Again, everyone should not forget these things. As we move forward, we learn. See, tomorrow you will go into some automation tool and you will be working. Don't forget your core Java. Don't forget your web concepts. Don't forget your testing fundamental concepts. The reason is, this should stay all your life. I won't mind if you forgot Selenium or if you forgot the QTP. If you are forgetting programming, if you are forgetting web concepts, testing fundamental concepts, core concepts, I agree, you are still in the course. I am not saying that you should be perfect. You will become perfect. But the more I am giving the importance, don't give importance to the tool. Give importance to the concepts a lot. Okay? You are just learning why. Right? Why we need concepts more than, because everything is changing. So, for example, you write a Java class. What will the extension of that class will be? .java. First .java. Then I compile it. What will I get? I will compile and I will get .class file. Agreed? And this, then when I run this .class file, JVM will convert this into machine code. This is called bytecode, will be converted to machine code. Okay? Generally, when was JVM created? When was JVM designed? JVM was designed in 1990s. Agreed? First when Java came, 1992 or 1991. Did they thought about mobile phones at that time? No. JVM is meant where you have a huge RAM, remember, this .class files have huge resources. This .class file has huge resources. Agreed? So they are very huge. And they can run on our desktops. They can run on our laptops because we have huge RAM, we have huge CPU and everything. Do mobile phones have huge RAM and huge CPU? No. If you use the same bytecode and if you convert it into machine code, only one app will be running on my phone. I can't see, like it will take so many, it will consume. That is the reason there is a person from Ireland, means he belongs to Ireland, and he belongs to a place called Dalvik in Ireland, Iceland or Ireland, I forgot. So he created this Dalvik virtual machine to take this byte code and convert it into Dalvik code, Dalvik machine code. So Dalvik machine code is a compressed Java code, which is suitable for mobile operating systems. Agreed? So it's a compressed Java code. Understood? So that is called Dalvik virtual machine. Agreed? Okay. So every developer will be using this thing, like, and then there will be application framework. Okay. Application framework is nothing but all these libraries are given to you in Java for developers. Okay. So there is a Linux kernel, there is an abstraction layer, and it put all these libraries, and these libraries are given by API. Means Java APIs. Means all the packages of Java are given to developers so that they can use Java programming language to code Android applications. So Android applications will be made using Java, but they will run on Dalvik virtual machine. They use the core libraries and they will run on Dalvik virtual machine, and they come here. Is everyone clear about this one? Can everyone speak about Dalvik virtual machine tomorrow? Yes. That's what I want. Okay. All right. Yeah. So generally, when you compile a Java class, you get dot class, right? But when you compile Java to Dalvik virtual machine, it's a DEX file, DEX file. That is called DEX, Dalvik executable. Java to Dalvik machines. So that is called Dalvik executable. Okay, DEX files. Okay, please use this. And Dalvik also has a jitter inside it. Remember just-in-time compilation? In JVM there is a just-in-time compilation, remember? Same Java, Dalvik also has jitter. Okay? Alright. See, when we used to get dot class, we used to get a dot jar. Remember, we make a jar of all these classes. For Dalvik, for Android phones, we compile Java and we make DEX files. Simple. It is very simple. Am I right? You write Java code, I will tell you. Before you used to compile for JVM. We are compiling now for DVM. Agree? You write Java files, you compile it. For DVM, you get DEX files. DEX file is a combination of for before you compile, you get dot class files. You get dot class files, and you combine all these dot class files into jar. Here you compile all the dot class files into DEX. Dalvik executable. Dalvik is not running on Eclipse. Dalvik is running on Android phone. You make code on Eclipse, and when you compile, you get DEX so that you can run it on Android phone. Am I clear? Agree? The programs we made in Eclipse for our laptop, but the programs now we are making are for Android. Wherever Android runs. Yeah, Ramani, please. Okay. All right. Core components. The core components of Android. There are 4 types of components in Android. Let's see. First one is called activities. Anything which is UI is called activity. So Bank of America screen is called an activity. You understood, right? So let's say, for example, yeah. Do you see, when I click the Bank of America, It opens the screen for me. This is called an activity. This screen is called an activity. This screen is called an activity. Agreed? This screen is called an activity. Agreed? So the activity is nothing but a foreground. What is showing up on the screen currently is called an activity. So activity has UI. Activity shows up on the foreground. Agreed? Am I clear? Activities are nothing but just like think like desktop applications. If you click a calculator, calculator will come up and show up. So it is like an activity. Activities usually correspond to display screens. Each screen activity shows one screen to user. Agreed? Every screen is an activity. An application is set of activities. Am I clear? So for example, when you are talking to your interviewer tomorrow, oh, my app had 4 activities, 2 services. You should speak like that. Don't tell that I have 4 screens. Understood? There is a difference. Agreed? I have 4 activities. Then there is a service. Service is something which doesn't have UI, which is running in the background. Agreed? Service is a activity without user interface. Am I clear? It is a program which is running, but it doesn't have, for example, notification. You get automatically a notification that you got a Gmail email or something, you got a Facebook like or something. Does it have UI? The UI it is showing up is Facebook UI. It is not the real activity UI. Okay, let me tell you. Activity is a screen, is a single page, Agreed? Activity is currently what is showing up. There are so many activities. When you click the next button, it will go to the next activity and everything. Agreed? For example, automatically something like there is a program running on the background. There is a program constantly going to your Gmail server with your login credentials, with your login details. You got a new email on the server. It comes up, this program comes up and it gives to Gmail app. It will tell the Gmail app that, oh, you got a new email. In the Gmail app, something will open up and say that you got a new email. Agreed? This program is called service. This program which constantly runs on the background. I will repeat this again. Alright, I will repeat this again. Alright, yeah. The program which runs constantly on the background without any face, it doesn't have any face, but it will tell some other activity to do something. It gives information to some other activity. Am I clear? So these are programs running without face and they support activities. They give information to activities. For example, weather alert, maps alert. Oh, there is a traffic, for example, there is an accident. Agreed? So these are all called services which are running on the background. Agreed? And for example, even though you minimize your iTunes activity, music is still playing. Audio is an activity. Audio is a service. iTunes is a activity. Am I clear? Your music app is an activity that is using audio service. Did I make any sense? Because even though you remove the activity from the foreground, agreed? Even though still you can hear the audio. Audio is a service. It doesn't need a face. It can still play you. But for selecting next song or anything, you have to use an activity from iTunes or whatever Raga or whatever the app you use. Understood? Am I clear here? Okay. So your application will contain, so everyone with mobile app resumes, your application will contain activities and services. So you need to tell what are the activities, write in your resume notes. Don't ask me. By tomorrow. What are the activities? What are the services? Then there is called broadcast receivers, intent receivers. Broadcast receivers and intent receivers. What is broadcast receiver? For example, battery is low. It needs to warn you, right? Broadcast means it needs to broadcast to the entire system, not for just one application. Agreed? Battery is down, or let's say I can, Bluetooth device connected. I read Bluetooth device connected, or Wi-Fi available. I can find some, some connections. All these are called broadcasting receiver. So they broadcast information to the phone, not to an app. Service is working on a specific function. Broadcasters need to broadcast to the phone, not to a specific app. You can build a service, you can build your own service. You can build broadcasters too. Okay? But broadcast will broadcast to everyone, not just one app. Service is doing a logic for something. Agreed? Broadcast is not doing logic for something. It is giving you something. It is broadcasting information. Okay? Sampath is asking me when are we going to be done? In 20 minutes, Sampath. Yeah. Yeah, I know it is pretty late for her because it's 3:30 already. Yeah. 3 o'clock already. Okay. Alright. Then there is intent receiver. Intent receiver means, for example, if you go and open an email, open this in some other thing. Remember, in Android, you can open a file in many things. Open with and this kind of other things. So their intent receiver means an app can receive information from another app. For example, help need your location. Agreed? Help need your location. Otherwise, if you don't get location, how do I go and get all this thing? Agreed? So that is receiving an intent information from another app. Agreed? But actually location is a service, not an app, not an activity. So that is not a right example. An activity giving to another activity, that is called intent receiver. An activity giving to another activity is called intent receiver. For example, let's say, I can't come up with an example. Hold on. Yeah, incoming call is an intent receiver. Incoming call is an intent receiver. Okay. It's a broadcasting. It should be broadcasting, right? It should not be intent one. Let's say, yeah, intent receiver. Wait a second. We'll find an example. That should be broadcasting. Means it's broadcasting to the phone. Yeah. For example, you want to compose an email. There are many email applications inside your Android. You can compose an email with Gmail. You can compose an email. So it will ask you, give the list of intents. You can. So for example, you copied information. You copied in some text on something. Oh, do you want to put it to Dropbox? Do you want to put it to Notes? Do you want to put it to, remember? Those are intent receivers. Where you want to send this? Understood? This kind of stuff is intent receiver. Agreed? Set of, for example, if you are doing an activity, there are people who are interested in that activity. These are called intent receivers. For example, you took a photo on an app. Oh, do you want to put it to Dropbox? Do you want to put it to Google Drive? They are interested in taking that information for you. They are intent receivers. Am I clear? But they are specifically interested on your photo. They are not interested for your battery low or anything. Understood, right? So they are broadcasters. These are receivers. Agreed? Yeah. And then there is content providers. Content providers means data. In your phone there is so much of data. Your contacts, your emails, your notes and everything. For example, when you are searching in an app, or you, for example, in Vonage app, you can go and get your contacts list. Means Vonage app is using the contacts content provider from the Android system. Am I clear? These are not services. They are not logic. They are set of data which needs to be provided to all the apps. Agree? For example, let's say all the pictures you can view it from Facebook. Go and upload to Facebook, upload to Google, you know. If you open the Google Drive or something, means this information, these are called content providers. They are data, they are not logic. Service is logic, which is running in the background. Broadcasting is information sending out to the phone, not to an app. Intent receiver is someone is interested in the information you are accessing currently. Mm. Yes, that might be intent receiver too. Yes, whatever you are giving, someone else also is interested in receiving that. Whatever you are doing, someone else also be interested in that. That is intent receiver. And content providers are the information in your phone, your images, your photos, your contacts. Agree? Your notes. All this is content providers. They are data. They are pure data. Someone wants to use it for some other purpose. For example, Vonage. Will Vonage phone ask you to create new contacts in Vonage phone app? No. It will use your phone contacts. So it is using the contacts content provider. No. Alright. See. First thing is, there are screens which run. They are called activities. There are programs running on the behind. Programs running on the behind. Okay. Behind. Okay. Agreed? There are programs running on the behind. Like for example, got new email or anything like that, you know. Got new email notifications or something like notifications for apps. Okay. Notifications for apps. These are called services which are running in the behind. Agreed? They are running in the behind. There are broadcast services too. Broadcast providers. Broadcast intent receivers and broadcast receivers. Yeah. Broadcast receivers means information or notifications about the phone or anything. So they send information to the phone. Okay, battery is low. Okay, someone is calling you, something like that. That is a broadcast receiver. Agreed? Alerts, phone alerts, not app alerts. Okay, then there is intent receiver. You took a photo. Someone will come up and say that, oh, do you want to upload to my Dropbox? Someone is interested in whatever you are doing now. But that app is not open. But that guy will come and, you know, will say that, okay, do you want to give me? Agree? That is intent receiver. Okay? Yeah. For example, you automatically copied something. You are reading a book, you copied. Oh, do you want to send an email this to something? Agreed? An email, Gmail will open, mail will open, some other thing will open, Facebook will open, or do you want to paste this as your status or something? Agree? So these are intent receiver. They are interested in whatever you are doing. They are always looking for you. Agreed? So they are intent receivers. Okay? And then there is content providers. Content provider means they have data. They are your phone data like contacts, images, okay? Contacts, images and everything, which you can spread out to all the apps, which Android will give available to all the apps. Vonage can use your contacts. Viber can use your contacts. Agreed? All the apps can use your contacts. Your Gmail can use your contacts on the phone. Agreed? So by default it is provided. Content provider is content to provide it to all the apps. Agreed? So these are the things. So now you understand. So in your app, for example, whatever the app, Western Union app or whatever the app it is, you will have a content. For example, Western Union, you want to do money transfer. You have to access the content provider. Maybe the recipient is in the content provider, is in the contacts. And in the Western Union, sometimes you need the services to background services running. And in the Western Union, for example, if you go, let's say, for example, you go to, let's say, it's all about money transfer, right? Okay. For example, you clicked on somewhere, there is a dollar amount or something. Western Union will say, do you want to transfer this amount? It's an intent receiver. Agreed? So you have to test these activities. You have to test the services. You have to test the content provide integration. You have to test that it is showing pulling all my contacts. When I say select a recipient from contacts, send to someone, money is sent to someone. On the send to someone there is a contacts link. Like if you click that it will show up all the contacts. Is it showing all the contacts or not? Why not? It will show only contacts with email, maybe not without email. You know, you need to come up with these scenarios. Agreed? And on the screen you will put 500. Agreed? And there is a service running in the behind. When the other person receives money, it will automatically give an alert saying that money received by that person. We cut you this much percentage for that. Agreed? So it's not a happy news always. Okay? Yeah. So those are some of the scenarios. Am I clear? Okay. Android life cycle. There is something called everything has a life cycle. Life cycle, remember, where did we learn life cycle? Test life cycle, bug life cycle. Android has a life cycle for service and activity. Agreed? So developers, when they develop, for example, I am a developer. Let's say I want to code Western Union program. I will go to Eclipse, right? Let's say I will go to Eclipse. I really didn't set up my Android or anything here. Okay. Yeah. For example, I am the Android developer for Western Union. Think like that. What will I do? I have to go to Eclipse. So think like this is my Eclipse. Okay. So I will say import android.activities.star android import android.services.star. Got it? So I will do this. First thing is my activity. Every screen is an activity. So I will say public Western Union. So let's say W. Western Union home activity means home screen activity. Okay. Extends Android activity. You understood right now what I am doing? So is Java coming back? Okay. I became an activity. Agreed? I became an activity. In this activity, I will say public void on. This is the life cycle. You have to write the life cycle. Every activity has a life cycle. On create means just when the activity is creating, means by the when you click on an icon, a screen comes up. Even before the screen needs to make up, right? Screen needs to make up what are the things. On create means okay. Then I will say create a layout equal to new layout. Layout equal to new layout. Okay. Okay. Means I am telling that create a vertical layout. Agreed? So something like that. I will create a layout. Then what will that? Public void on start. Start means it is almost ready. Got it? It is on create means it is creating. On start means it's ready for your usage. Agreed? So what should I do? On start, for example, if this guy never logged in, if it was not logged in or anything, I will say please log in. Okay? Or I will say if this guy logged in, do I need to show home screen or directly to another screen? Like redirect to another screen, redirect to another activity, next page. Got it? Next page. You are already logged in. I have your login information saved. So let me move to your transfer page. Agree? So I will write like code like that. Now, for example, public void on pause. On pause means this guy hit home screen or something. This guy hit home screen. He is about to transfer money, but he changed his mind and he hit home screen. What should I do? Okay, go and sleep my this one, or go and do like, kill this activity or something. Agreed? So that I don't use your CPU and your data and anything. Otherwise, I will be constantly using your data and everything. And on resume means you came up with the app back again. On resume, public void on resume. You are making my app back again. You are making my app come back again. Agreed? That is just before coming. On stop means you stop, means on pause. On pause means just before stopping. Stop means stop. Destroy means you killed it. Agree? Destroy means you killed it. So that is the life cycle of an activity. So you have to program. Developers program for the life cycles of your activities. Developers program life cycle for your services. So there is on bind also, because service can bind to something else. Service is providing information to some activity and it will bind it to an activity. So there is an on bind also. Agree? So that is, you asked me why should we write base classes. Remember, think like this is a service instead of an activity. I will write public void on bind and I will say service my service. Sorry, activity service. This is a think like this is a service. I am writing a service. For example, I am writing a notification for Gmail or notification money received. Okay, money received for Western Union. So on bind I am let me write again one more thing. Okay, this is money received service and I will say extends Android service. Agreed? And here I will write on bind and I will say on bind a service will bind to what? An activity. Remember? So you will pass an activity. Is this a base class or a sub child classes? The signature will be base class. From this activity, any activity can come. Understood? It can be a Western Union activity. It can be a Gmail activity. It can be. So when you write your signatures as a base class reference, any child class can come. You understood? Remember, employee equal to new employee. Why do you want to put employee equal to new manager? Why do you want to put manager into employee? Because manager can go as employee anywhere. Everything is an activity. So I can bind to any activity. I am not hard coding my signature. By using the base class reference, I can bind to any activity. That can be Gmail activity tomorrow. That can be Google Western Union activity. That can be some other activity. Understood? So I can bind to any activity. Am I clear? If not, you will get it later. Okay? That is the reason of using base classes. That is the beauty of polymorphism. Yes? No, you don't have to write. I am just telling how developer is writing program for you. So now tomorrow, what are you testing in Western Union? Oh, we used to have Western Union money received service. We used to have. So I tested like on create methods, on means we used to make sure everything is running properly. Sometimes this on pause method never used to run. So when I pause that app, that program never runs because it used to do this thing. So I told the developer and developer fixed this on pause method for this service. I don't want you to program it. I want you to learn the structure of programming. We don't know how an Android app is made. How will you test an Android app? We don't need automation tools. Am I clear here? Where am I getting? Yeah. Even though you can tell this with manual testing. If you know what is the difference between pause, stop and destroy, that small thing when you just click the home button, there are 3 activities taking place. Pause, stop and destroy. Okay. So you can do that where it is going wrong. So you can tell your developer and the developer will fix in one of this method. Can I change to PDF or PPT? Yeah. Okay. Okay. I want you to learn Android. Do we need these codes to test? You don't need this code to test. You need to know what is the life cycle methods. You need to test the app at each life cycle. On start, on destroy, on stop, on pause. If you are really white box tester, you can test everything in Java only. Agree? If you are a white box tester, remember? You don't have to use Android phone itself. Direct test that code. That code is Android activity. If that code is wrong, everything is wrong. Am I right? But you are not white box tester, right? So that is the reason. Okay. All right. Let's move forward. So I wrote these Java classes. I'm a developer. I wrote these Java classes. Okay. And generally, what does Android application look like? For example, if I am a developer, how does Android application look like? For example, this is an Android project. This is an Android project I made myself. Okay, think like this is the Western Union project. Let's say Western Union app. Western Union Android app. Western Union Android app. Okay. Yeah. And here I will have a folder called source. What is the source means? All the Java files I wrote. Then there is a folder called resources. Resources means in my code did I tell, I told what the activity should do. Did I tell how the activity should look like? No. Did I tell how the what colors the activity should have? Did I build the user interface? I told what the user interface should contain and how should the logic be done. Did I tell how it should look, what colors, what fonts and everything? That is all in this resource file. What is the image and everything? So that is all in this resource file. So in resource file, in this resource, so Java code goes into source code. Agreed? Resource file will all have the styles, presentation, layout and everything. So what are the folders and everything in the resource file? Let's go and see that. Okay. In the resource folder, am I recording this? Yeah. There will be layout. You will write layout. Layout means what is the template of that screen. Then there will be animation. For example, you have any cool animations. For example, games. For games there will be animation folder. All the animations will go there. Drawable. Drawable means any canvas or any these kind of fields will be. For example, you need to do signature somewhere on that Western Union place. That is a drawable. Agreed? So they will give the region. This much should be the drawable region and everything. So values. What are the values? For example, on the home page, what should look like? For example, Western Union. And for example, what is the value of this field? This field will have like username, password. All these are values, means string values. Okay. And colors. You can have colors. So each one will have folder. Color, XML, menu and raw. Raw means, for example, you want when the app opened, you want to show a video. It will give a presentation to you. Welcome to Western Union. Now you will be using this app to transfer. That video you can put in the raw folder. You can put all the diagram. For example, you can put all the images. You might have images to show up logos and everything. Logos and everything you can put that. So, but now I told a folder for each one. What will you have in this folder for colors and everything? XML files. Everything is defined using XML. I want this color. I want this layout. Everything is an XML file. So Android is all about XML and Java. Do you know both of them? Yes, you know both of them. Agreed? You can become a Java Android developer if you would like to. Definitely, actually, if you want, you can become a Android developer by yourself. Yeah. Okay. All you need is XML and Java. I taught you both of them. Okay. I will be done because I only have 2 slides. I will be done and okay. So that is one thing. So that is how it is. Then more important 2 things I need to tell. XML files. For example, this will have main.xml. Everything will have a file called main.xml. We see this main.xml. In every folder there will be something, this is for animation. This is for colors. This is for, you will put all the definition of the images and you will put your images also here. Everything will have a XML file. Definition of colors in XML file. You don't create a color. Everything is there in Android. You are just configuring. You understood, right? What are you trying to do? You are just creating activities, services, and you are using existing content providers and you are putting the layout in XML files. So isn't Android development easy for a developer? Think from your perspective. If you think you can come to this far, don't you think Android development is easy? Do you know why there are more apps now in Android? Yeah. This source, now this source is all about Java files. But But you need to compile this Java files, right? When you compile this Java file, what will you get? You will get DEX files. Agreed? But remember, you don't need to make a DEX file. Finally, you need to make a single app, right? That single app is called APK file. When you compile all the source and XMLs, everything goes into a file called APK file. So if I have a APK file, if I give you that APK file, you have that app. For example, I bought Western Union app purchased for $5. I have that APK file. If I can give you that APK file, you got everything. Agreed? You got everything. So that is called APK file. APK file is what? Is the application package file. It's called Android package. It's called an Android package. Like we have exes on Windows, right? If you have that exe, you got everything, right? So like the exe, that is called application package file. So we make a APK file. And then there will be a manifest file, Android manifest. So all this layout and everything will come into this one. And that is called Android manifest.xml. So tomorrow if you want an app from me, if I give you APK and Android manifest.xml, you got the app. You can go and change this Android XML, how it looks. For example, Android XML tells that this APK, where is it looking for Java code? What are the services and components using from Android SDK? What are the permissions for this APK? So you can put all in the Android manifest.xml. Let me show you.
I think that what the APK file will have the source file and the manifest files and the XML files too.
I will tell you. 1 second. Yeah. Okay, so see this one, this is a manifest file. In that, right, you will write a, for example, you will write manifest, ending with manifest. You will write application. This is my icon. So to click the open this app, you need this icon. Actually, I need to zoom it, right? Okay, no problem. Let's go for here directly. I'm almost done. I'm very sorry. I'm not good at giving breaks, but I'm done. Please bear with me. We will finish some of the Android today. Okay. See, if you see, this is the manifest file. In that manifest file, you will have an application tag, means you are defining an application. You will tell what is the icon to click to open this app. What is the label on that? Means you can have a label, right? Okay. And what are the activities inside this? What is the starting activity? What is the first activity to load? Then what are the intents for this? So you are putting everything into XML. You might write code, how to start, from which activity, the flow and everything of this application. But you don't put all these layouts and everything. This will have, it will tell my layouts are in this folder. My Java DEX files are in this folder. You understood, right? Okay. So APK, when you compress APK is only about code. Okay. It's a package. Actually, I think it will have the XMLs too. DEX files and XMLs too. It's a package of DEX and XMLs. Okay. What is APK? It's a package of DEX and XMLs. But in that package, there are many folders, right? There are many folders like layout, animation, fonts, colors and everything. You need to tell in the manifest where is where, which is where, what is the first. You are mapping, you are telling the structure, which one to start first. Agreed? Which activity to start first. Where is my home button, where is my start icon. What is the label of my app, and you are configuring that. Alright. Can you zoom in? Okay, very good. Let's zoom. I think this is the end of zoom. Yeah. Okay, I will tell you one thing again. So this I will, when I compile, source will become dex, right? All this XMLs and everything, the dex will be packaged into what file called APK file, application package file.
Only the text files.
No, both of them, XML and everything, both will become what? APK file. It's a package. It's like putting in a zip. It's putting in a RAR. Am I clear? Okay. So, but I don't put Java code inside it. I compile the Java code into what? Dex. Agree? I compile the Java code into Dex and I do all this into this one. What did I get? APK. But when who knows where to start and everything. So I will write something called APK and next I will write Android manifest.xml and tell that this is my icon. This is my name of this app. This is my start activity. These are my services. You are configuring. Agreed? That is the configuration file. What is that called? Manifest file. Android manifest.xml. Am I clear? Okay. An APK file. All right. So then how to test it? Actually, I told you everything other than how to test it. Yeah. All right. So this is it for now. I can't do tomorrow. I have a couple of